Suppose we use the staircases where we increase the dimension by 1 each time. We start with 1 block. We then use 3 blocks to build the staircase with dimension 2 by 2. And then we increase it by 1 to build a 3 by 3 staircase where we use 6 blocks. And then 10 blocks, 15 blocks, and 21 blocks. Naturally, the question is, how many blocks do we need to build the next staircase? This is a sequence where a sub 1 equals 1, a sub 2 equals 3, a sub 3 equals 6, a sub 4 equals 10, a sub 5 equals 15, and a sub 6 equals 21. By studying this sequence, we know that this is not an arithmetic sequence because 3 minus 1 is 2, 6 minus 3 is 3. There is no common difference here. It is also not a geometric sequence because 3 over 1 is 3, 6 over 3 is 2, and that is not a common ratio. Observe the first difference from 1 to 3 to 6 to 10 to 15 to 21. The first difference is the difference between any two consecutive terms. From 1 to 3, 3 minus 1 is 2. From 3 to 6, 6 minus 3 is 3. From 6 to 10, 10 minus 6 is 4. From 10 to 15, 15 minus 10 is 5. And from 15 to 21, 21 minus 15 is 6. And we see that the first difference, even though they're not the same, that is because we do not have a common difference, the first difference increases by 1. So we will find the second difference. The second difference are all 1. This is the difference between any two consecutive terms. If the first difference will give us a linear function, then the second difference will give us a quadratic function. And so we see that this will be a quadratic equation, and the n term will have the formula where it will be a quadratic an squared plus bn plus c. This is ax squared plus bx plus c. If this formula will represent the n term, then it should satisfy these conditions as well. The domain of this function is the set of integer n go from 1 to 2 to infinity. These are counting numbers. And the range will be a sub n. A sub n is the function in terms of n. From the sequence, we see that when n equals 1, f of 1 is 1, or a sub 1 equals 1. When n equals 2, f of 2 is 3, where a sub 2 is 3. When n equals 3, f of 3 is 6, where a sub 3 is 6. To find the formula for this a sub n, which is a quadratic with 3 parameters a, b, and c, we only need 3 points. So we will set up the system of equation. A n squared plus bn plus c equals a sub n. If we were to use n equals 1 and a sub 1 equals 1, then we have the first equation, a times 1 squared plus b times 1 plus c, where n equals 1, and a sub 1 is 1. This is when n equals 1. When n equals 2, a sub 2 is 3. If we plug 2 into n, we have a times 2 squared plus b times 2 plus c equals a sub 2. A sub 2 is 3. And when n equals 3, a sub 3 equals 6. If we plug 3 into n, we have a times 3 squared plus b times 3 plus c equals 6. And we end up with a system of equation a plus b plus c equals 1. 4a plus 2b plus c equals 3. 9a plus 3b plus c equals 6. Solving this system of equation, we will get a equals 1/2, b equals 1/2, and c equals 0. We can solve this system of equation either using elimination, substitution methods, or we even set up the augmented matrix as well and use a calculator to find the reduced row echelon form. A sub n is therefore 1/2 n squared plus 1/2 n plus 0. If we factor out 1/2 n, then we end up with 1/2 n times n plus 1. And this is the formula for a sub n. This will tell us how many blocks we will need to use for the nth staircase. Let's check this. When n equals 1, 1 plus 1 is 2. 2 times 1 is 2. 2 divided by 2 is 1. When n equals 2, 2 plus 1 is 3. 1/2 times 2 is 1. 1 times 3 is 3. When n equals 3, 3 plus 1 is 4. 4 times 3 is 12. 12 divided by 2 is 6. And notice that we did not use n equals 4 to come up with this system of equation. But what happened when n equals 4? When n equals 4, 4 times 5 is 20. 20 divided by 2 is 10. So yes, this is the formula for the n term. A shortcut to find the formula for the n terms of a quadratic sequence is take the second difference and halve it. This will be the coefficient of the n squared term. And then check this. When n equals 1, the first term is 1/2. When n equals 2, the second term is 4/2. When n equals 3, the next term is 9/2. When n equals 4, this is 16/2. When n equals 5, this is 25/2. This is 1/2, 2, 4.5, 8, and this is 12.5. We then find the difference between these coefficients and the given coefficient or the given terms. The first difference, 1 minus 1/2, is 0.5. The next one, 3 minus 2, is 1. The next one, 6 minus 4.5, is 1.5. 10 minus 8 is 2. 15 minus 12.5 is 2.5, and so on. These are the numbers that we need to add to 1/2 n squared to get the original given terms. Meaning, if we were to use 1/2 n squared, we only get 1/2. We need to add 1/2 more to get to the original one. If we use 1/2 n squared, when n equals 2, we have 2, so we need to add 1 more to get 3. When n equals 3, we get 4.5. We need to add 1.5 more to get 6, and so on. But observe that when n equals 1, we would need to add 1/2. When n equals 2, we need to add 1. When n equals 3, we need to add 1.5. When n equals 4, we need to add 2. When n equals 5, we need to add 2.5. What this means is that we need to add 1/2 of n. 1/2 of 1 is 0.5, 1/2 of 2 is 1, 1/2 of 3 is 1.5. And so the formula for the a sub n term is 1/2 n times n plus 1. This works, but it is not as intuitive as the one that we did earlier when we used the system of equations.